Welcome to Raw Private Classes. I am going to start again posting videos on YouTube channel. First video I am posting about ad hoc and wireless sensor networks. Now first is what is a wireless sensor network? Wireless sensor network is an infrastructure-less wireless network which is deployed in a large number of wireless sensors in ad hoc manner and which is used to monitor the system physical or environmental conditions. Wireless sensor network use sensor nodes with on-board processors for managing and monitoring the environment in a particular area. They are connected to base station and acts as a processing unit in wireless sensor network system. Base station in wireless sensor network system is connected through the internet for sharing the data. You can see the architecture of wireless sensor network. Now, sensor network architecture which is used in wireless sensor network, and it can be used in different places like schools, hospitals, buildings, roads, etc. for different applications like disasters management, security management, crisis management, etc. Mainly there are two types of architectures which are used in wireless sensor network. Number one, layered network architecture. Number two, clustered architecture. Layered network architecture means it makes use of few hundred sensor nodes and a single powerful base station. Network nodes which are organized into concentric layers. It consists 5 layers and 3 cross layers, and these 5 layers are: number 1 power management, number 2 mobility management, number 3 task management. And it is a two-tier hierarchy clustering architecture. It is a distributed algorithm for organizing these sensor nodes into groups called clusters. The cluster heads nodes in each of the autonomously made clusters create the time division multiple access schedules. It also makes use of concept that is called data fusion, and which makes its energy efficient. And you can say that sensor network architecture is increase the scalability, flexibility, energy efficiency, and it also used for distributed processing, for self-organizing. But some disadvantages in this wireless sensor network architecture like complexity, security, vulnerabilities, interference, cost, limited range. These are the disadvantages of architecture of WSN. Now I am going to discuss about applications of wireless sensor network. Wireless sensor networks have gained considerable popularity due to their flexibility in solving their problems in different application domains, and they have the potential to change our lives in many different ways. Now, wireless sensor networks have been successfully applied in different application domains like military application, area monitoring, transportations, health application, environmental sensing, industrial monitoring, agriculture sectors. First is military applications. Wireless sensor network is used for monitoring the enemies in military application, in military areas. It is an integral part of military command, control, communications, computing, intelligence, battlefield surveillance, and targeting systems. Second is area monitoring. In area monitoring, we can say that sensor nodes are deployed over a region where some phenomena is to be monitored. When sensor nodes detect any event, which is monitored by wireless sensors like heat, pressure, etc. The event is reported to one of the base station and which then takes appropriate action. Third is transportation. Real-time traffic information which is collected by wireless sensor networks to later feed the transportation models and to alert the drivers of the congestion and traffic problems. Health applications. Some of the health applications is used for sensor networks. They are supporting interfaces for the disabled, integrated patients monitoring, diagnostics and drug administrations in the hospitals, telemonitoring of human physiological data and tracking and monitoring doctors or patients inside a hospital. Environmental sensing. The term environmental sensor networks has developed to cover many applications of wireless sensor networks to earth science research, and this include sensing volcanoes, oceans, glaciers, forests, etc. Some other major areas are listed below: air pollution monitoring, forest fire detection, greenhouse monitoring, landslide detection. In all these areas also use wireless sensor network for monitoring them. Next, structural monitoring. Wireless sensor network can be utilized to monitor the environment within the building's infrastructure such as bridges, flyovers, tunnels, etc., enabling engineering practices to monitor the assets remotely without the need for costly site visits. Next, industrial monitoring. Wireless sensor network also used for industrial monitoring. We can say that wireless sensor network have been deployed for machinery, condition-based maintenance, as they offer significant cost savings and they enable new functionalities in wired systems. The installation of enough sensors is often limited by the cost of wiring. Agriculture sectors. In agriculture sector also wireless sensor networks are used. Here wireless sensor networks are used to free the farmers from maintenance of the wiring in a difficult environment, and irrigation automation enables more efficient water use and reduces waste. Now I am going to discuss about what are the applications of ad hoc network and its problem. With the large number of small size gadgets also as advancement in the remote communication, ad hoc networking which is picking up the exertions with the large number of far reaching applications, ad hoc networking which can be utilized whenever any place with restricted or then again no correspondence framework. The first framework is irritating to the utilize the ad hoc network architecture which can be utilized continuous business applications, corporate organizations to expand the efficiency and benefits. The ad hoc network which can be arranged by their applications like MANET and BANET and WSN. MANET means mobile ad hoc network which is self-organizing infrastructure less system of cell phones communicated through the remote connections. And BANET means vehicles ad hoc network which is utilizes vehicles as nodes in a network to make the mobile network. WSN, that is known as wireless sensor network which comprises of independent sensors to control of ecological activities. Now what are the uses of the ad hoc networks? First use is military. In military we use the ad hoc network, personal area network, crisis condition, medical application, environment application. Military, an ad hoc networking will give access to army to maintain a network among all the soldiers, vehicles and headquarters. PAN means PAN is a personal area network which is a short range local network where each nodes are usually related with a given range. Crisis condition, because it is fairly easy to create, it can be used in the time of crisis to send emergency signals. And medical application, which can be used to monitor the patients. Environmental application, which can be used to check the weather condition, forest fire, tsunami, etc. Now, what are the problems and what are the issues which are facing by ad hoc network? First problem, limited wireless range. Second problem, packet losses. Third, energy conservations because of limited batteries. Energy conservations means energy saving. Low quality communications. Hidden node problems creates collisions if two devices try to communicate with same receiver. Exposed node problems, lack of security. Now next point I am going to discuss, that is routing protocol for ad hoc wireless network. What is a routing protocol? What is a routing? Routing is the process of finding the best path for traffic in a network or across multiple networks. Main role of routing is just like similar to the road map, which is used for going to the any hotel, any place. In both cases, we need to deliver the messages at a proper location and in an appropriate way. Routing is a mobile ad hoc network which depends on the many factors like modeling of the topology, selection of the routers, initiations of route request, and specific underlying characteristics which could serve as a heuristics in finding the path effectively. In a minute, every node or device is exposed to serve as a router, and each router is different from another in the sense that all router execute same routing algorithm for computing the path through the entire network. Now, what is the need for routing? Why we use the routing? Routing protocols which are used to distribute routing information between the routing devices. There are following needs for routing. Number one, because centralized routing in a dynamic and even for small network is impossible. So, routing calculation must be distributed. Second need, route calculation should not be add many more nodes. Number 3, if any host demands for the route, they must have quick access. Maintenance of a global state should not involve in the route calculation. Every node should care about their destination node to its route and should not be involved in the frequent topology which updates for these portions of the network which have no traffic. Because broadcast can be time consuming for minutes, it must be avoided as much as possible with the help of routing protocols. In routing, there must have a backup route when the primary route has become stale. Now, next topic is, what are the classification of routing algorithms? Routing is the process of establishing the routes that packets must follow to reach the destination. In this process, a routing table which is created and which involves information regarding routes that data packets follow. Various routing algorithms which are used for the purpose of deciding which route and incoming data packets needs to be transmitted on to reach destination efficiently. Routing algorithm which can be classified as follows. Number 1, adaptive algorithms. You can use non-adaptive algorithm. You can use hybrid algorithm. But what are the difference between the adaptive algorithm, non-adaptive algorithm and hybrid algorithms? Now I am going to discuss about these algorithms. These are the types of routing algorithm. Number 1, adaptive algorithm. In adaptive algorithm, further divided into 3 parts: isolated, centralized, distributed. Non-adaptive algorithm further divided two parts, flooding and random walk. Hybrid algorithm which further divided in two parts, link state and distance vector. Now first I am going to discuss about what is the adaptive algorithm. Adaptive algorithm are those algorithms which change their routing decisions whenever network topology or traffic load changes. The changes in the routing decisions, they are reflected in the topology as well as the traffic of the network. So that's it known as dynamic routing, and these make use of dynamic information such as a current, topology, load, delay, etc. for selecting the routes. Optimization parameters, arguments which are distance, number of hops and estimated transmit time. Further, these are classified as follows. Number 1, isolated. In this method, every node makes its routing decisions using the information it has without seeking information from other nodes. The sending nodes don't have information about the status of particular link. And the main disadvantage is that packets may be sent through a congested network and which may result in delay. For example, hot potato routing and backward learning. Centralized. In this method, a centralized node has entire information about the network and it makes all the routing decisions. The main advantage of centralized is only one node which is required to keep the all information, all network, about all the network. But disadvantage is that if that center node goes down, the entire network also goes down. The link state algorithm, which is referred to as a centralized algorithm because it is aware of the cost of each link in the network. Distributed. In this method, the node which receives information from its neighbors, then they takes the decision about routing the packets. A disadvantage of this distributed is that packet may be delayed if there is a change in the between intervals in which it receives information, and it sends the packets, which is also known as decentralized algorithm, and it calculates the least cost path between the source and destination. Now second point is non-adaptive algorithm. Those algorithms which do not change their routing decisions once they have been selected. And this is also known as static routing. Adaptive algorithm is known as dynamic routing, and non-adaptive algorithm is also known as static routing because it do not change one time it has selected. And this is also known as static routing, as a route to be taken is calculated in advance and downloaded to routers when a router is booted, router is started. Further, these are classified as follows. First, flooding. This adapts the technique in which every incoming packet is sent on every outgoing line except from which it arrived. One problem with this is that packets may go in a loop, and as a result of which a node may receive duplicate packets. And these problems can be overcome with the help of sequence numbers, hop, count and spanning trees. Next is random walk. Random walk means in this method packets are sent host by host or node by node to one of its neighbors randomly. Not sequentially, it is randomly. And this is a highly robust method which is usually implemented by sending packets into link which is least queued. You can see this figure. Here you can see initial point, and from initial point it go 1, then it go 2, 3, 4, 5, 6, 7, 8, 9, 10, then final position. This is the random walk. Now next is a hybrid algorithm. Hybrid algorithm, its name suggested that it is a combination of adaptive and non-adaptive algorithms. In this approach, network is divided into many regions, and every region uses a different type of algorithm. But further, these are classified as follows: link state and distance vector. Link state. In this method, every router creates a detailed and complete map of the network, which is then shared with all other routers. This allows for more accurate and efficient routing decisions to be made. Distance vector. In this method, every router maintains a table which contains information about the distance and directions to every other node in the network. This table is then shared with other routers in the network. The disadvantages of this method is that it may lead to routing loops. Now, next topic is table-driven routing protocol. What is a table-driven routing protocols? In a table-driven routing protocols, each node maintain one or more tables, including routing informations to every other nodes in the network. All nodes update these tables so as to can maintain the consistent and up-to-date view of the network. Proactive routing protocol that is used in table driven routing protocols. So that's why it is also known as table driven routing protocols. In mobile ad hoc network, nodes do not know the topology of their network. Instead, they have to discover it by their own, as the topology in the ad hoc network is a dynamic topology. The basic rules is that a new node, whenever enters into an ad hoc network, they must announce its arrival and their presence. Then they should also listen to similar announcement broadcast made by other mobile nodes. This is a table driven routing. Now I am going to discuss about managed routing protocols. Managed routing protocols further divided into three parts: proactive, reactive, hybrid. Proactive, DSDV and GSR. Reactive, DSR, AODV, hybrid, ZRP. Now first, proactive routing protocols. These are also driven routing protocols. Means you can say that table driven, also known as proactive routing protocols, or you can say proactive routing protocols, also known as table driven routing protocols. In this, every mobile node maintains a separate routing table which contains information of the routes, all the possible destinations of the mobile nodes. Because topology in the mobile ad hoc network is a dynamic, and these routing tables are updated periodically as when the network topology changes. And it has a limitations that it does not work well for the large network area, as the entries in the routing table becomes too large, so they need to maintain route information to all possible nodes. Now first point, destination sequenced distance vector routing protocol, which is a part of proactive routing protocol. It is a proactive table driven routing protocol, and it actually extends the distance vector routing protocol of wired network, as the name suggests. You can say that it is based on the Bell-Manford's routing algorithm. Distance vector routing protocol, which was not suited for mobile ad hoc network, so that's why, due to count to infinity problems, as a solution, destination sequence distance vector routing protocol came into existence, and destination sequence number is added with the every routing entry in the routing table maintained, which is by the every node. A node will include new update in the table only if entry consists of the new updated route to destination with higher sequence number. Second point is global state routing, that is known as GSR. It is also known as proactive routing protocol or table driven routing protocol, because it actually extends the link state routing of the wired network. It is based on the Dijkstra's routing algorithm. Link state routing protocol, which was not suited for mobile ad hoc networks. So that's why each node floods the link state routing information directly into the whole network. That is global flooding, which may lead to the congestion of control packets in the network. Hence, as a solution, the global state routing protocol which came into existence, and global state routing doesn't flood the link state routing packets globally in the network. In GSR, every node of a mobile node, each of the mobile node maintains one list and three tables: adjacency list, topology table, next hop table, and distance table. Now, second point is reactive routing protocols. These are also known as on-demand routing protocol. In this type of routing, route is discovered only when it is required. The process of route discovery occurs by flooding the route request packets throughout the mobile network. It includes of two major phases. Number one, route discovery. Second, route maintenance. Now, first point under this topic, dynamic source routing protocols. It is a reactive on-demand routing protocol. So in this type of routing, route is discovered only when it is required. The process of route discovery, which occurs by flooding the route request packet throughout the mobile network. And in this type of protocol, source node stores the complete path information, and intermediate nodes, they do not need to maintain routing information, and it consists two type of phases: route discovery, route maintenance. What is a route discovery? This phase decides the most optimal path for the transmission of data packets between source and destination mobile nodes. Route maintenance means this phase performs the maintenance work of route as a topology in the mobile ad hoc network, which is a dynamic in the nature, and because there are many type of cases of link breakage which resulting in the network failure between the mobile nodes. Now, second is a ad hoc on demand vector routing protocol, which is also known as AODV, and it is also called reactive on demand routing protocol because it is an extension of dynamic source routing protocol, and it also helps to remove the disadvantages of dynamic source routing protocol. In the dynamic source routing protocol, after the route discovery, when the source mobile node sends the data packets to the destination mobile node, it also contains the complete path in its header. Hence, as the network sizes increase, the length of complete path also increases. The data packets header size also increases, which makes the whole network slow. Hence, ad hoc on demand vector routing protocol came in existence for solving this problem. The main difference lies in the way of storing the path. In AODV, source node does not store complete path information. Instead of that, each node stores information of its previous node and next node. So it also operates in two phases: route discovery and route maintenance. And third point is hybrid routing protocol. It basically combines the advantages of both reactive and proactive routing protocols, and these protocols are also adaptive in nature, and they also adapt according to zone and position of the source and destination mobile nodes. One of the most popular hybrid routing protocol is zone routing protocol, that is known as ZRP. The whole network is divided into different zones, and then position of source and destination mobile node is observed. If source and destination mobile nodes are present in the same zone, then proactive routing is used for the transmission of data packets between them. If source and destination mobile nodes are present in different zones, then reactive routing is used for the transmission of data packets between them. This is the network of zone 1, zone 2, zone 3, and zone 4. If they all are the different, then we use the reactive routing protocol. If they all the same, then we can use the proactive routing protocol. Thank you. If you like my video, please like and share my channel for next coming videos related to ad hoc and wireless sensor networks. Thank you.